Good morning, friends. Today is Republic Day. India is celebrating 26th. India is celebrating 73rd Republic Day on 26th January 2022. And now, on this auspicious day, I request to all my viewers to subscribe my channel with the view that I will emulate, I will inspire to do my work with a good intention. In the last lecture, the chapter we have already learned, UV visible spectroscopy, some part of UV visible spectroscopy related to TYBSc analytical chemistry. Now, in this lecture, the next part of UV visible spectroscopy, we deals with the study of what is the difference between the colorimetry and spectrophotometry. So, what should be the parameters? What is the difference between them? So, before start the lecture, we should know solution. What is the definition of solution? Solution is nothing but the combination of two entities, solute and solvent. Solute is added in a small concentration into a higher concentration solvent to form a solution of a particular concentration. In that colorimetry, basically the colored solution is employed to determine the intensity of solution. From that intensity of solution, we determine the concentration of that solution. For the colorimetry, solution must be colored. That is the first condition. So colorimetry is used to determine the minute concentration of colored substance in the solution. The colorimetric analysis is based on the absorption of electromagnetic radiation from a suitable source. In the colorimetry, basically, tungsten filament lamp is used as a source of light, and photocell is used to detect the intensity of transmitted radiation. Whatever the intensity of incident light on the sample which get absorbed in that colored entities or colored moieties, and the reflected radiation in the form of transmitted radiation are captured by the cell. This is the basic principle of colorimetry. For example, if you take the solution of KMnO4, now KMnO4 having different concentration, 1% KMnO4 if you take, for 1% KMnO4, 1 gram of KMnO4 that should be dissolved in a 100 ml distilled water to form a 1% solution of KMnO4. For 5% KMnO4 solution, 5 gram of KMnO4 that should be dissolved in 100 gram of distilled water to form a 5% KMnO4 solution. Now the concentration of 1% is less and concentration of 5% is high. Naturally, whatever the intensity obtained in KMnO4 in two different glass tubes having 1% and 5% labeling, the intensity of 1% that should be less and 5% that should be higher. That means the pink color of KMnO4 appear in a small concentration in 1%, while in 5% the concentration of pink color will be greater. And we can easily recognize the intensities, and from that intensities we can determine the concentration of KMnO4 solution. If sometimes solution should not be colored, at that time solution should bring into a colored form, in a suitable form. If the analyte is not colored, that analyte should be colored, should convert into such a form that should be colored. For example, Fe3 plus ion. Fe3 plus ion that should be added into potassium thiocyanate. A red color is developed, and from that intensity of red color we can determine the concentration of Fe3 plus ion. Now there are the two methods. One is comparison method, another is photoelectric colorimeter. Now the comparison method, in that comparison method, two solutions are compared. The two colored solutions are compared and their intensities are measured and the concentrations are determined with the help of some such instruments. Now this color comparison method is least accurate and least sensitive. While in photoelectric colorimeter, photocells are employed to determine the exact intensity of and exact concentration of colored solution or colored complex solution. Now photoelectric colorimeter is mostly accurate, mostly sensitive method. So photoelectric colorimeter has a high advantage over the comparison method and it is greatly employed. Now the next one is spectrophotometry. Spectrophotometry is the combination of spectrometer and photometer. The name itself suggests that spectrometer and photometer. In ordinary colorimeter, tungsten filament lamp is employed as a source of light to give the polychromatic light. Now the tungsten filament lamp is generally used to obtain the polychromatic light. Polychromatic light has a different wavelength. This light polychromatic radiation, this light is polychromatic because it contains different wavelength. The selectivity and sensitivity of colorimetric determination can be greatly increased by using monochromatic radiation, that is a radiation having similar wavelength. Now mostly monochromators are placed before the source of light to obtain the monochromatic light. Now this monochromatic light that should have a particular wavelength, and this particular wavelength is useful in the determination of spectrophotometer. To obtain the similar wavelength, a monochromator has been placed after a source of light. We get the monochromatic light. Such instruments are called as spectrophotometer. Now this is the most important. Spectrophotometer. What is the definition of spectrophotometer? Generally, what is the difference between the colorimeter and spectrophotometer? So in that colorimeter, we do not employ a monochromator. Most important sentence. In the colorimeter, we do not add a monochromator. Only filter is used in colorimeter. But in spectrophotometer, a monochromator is employed to obtain a light of particular wavelength. And this light of particular wavelength is useful to determine the concentration of substance. The function of spectrometer is to provide the radiation of selected wavelength, and that of the photometer is used to measure the intensity of transmitted radiation. Now these transmitted radiations are useful to determine the concentration of substance. This is all about what is the difference between the colorimetry and spectrophotometry. Thank you very much.